what is the question right now? We are given two integers n and k, right? So here we are missing n and k integers, right? So we have to return all the possible combinations of k numbers chosen from the range 1 comma from 1 comma. Here in this case we have to go with 1 comma 4, 1 to 4, k equals 2 means two numbers we have to consider, right? The range, two numbers we need to consider. Here see n equals 1, k equals 1, and we have to go with only one number, right? So that's what the question states. Given that two integers n and k, return all the possible combinations of k numbers chosen from chosen from the range 1 comma n. So we may return the answer in any order. Order doesn't matter here, right? So this is why n equals 4, k equals 2. So we have to go with 1 to 4. See here, yeah. So we have to go with 1 to 4, right? So 1 to 4 we have to go, and k we have to consider 2. Means k equals 2 means here in this case we have to consider the range 2, right? So two numbers we have to consider into the range, right? So this one will be 1 comma 2, 1 comma 3, right? Uh, yeah, 1 comma 4. Same method. I don't have to write this one 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 4. These are the combinations, right? So other three this goes on. So basically we have n equals 4 and this one k equals 2. Total we will be having 6 combinations. Nothing but 6 combinations here, right? So 6 combinations means 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 4. These are the 6 combinations. This is not 4 plus 2 basically. This is basically not. So this is not actually 4 plus 2. So I just wanted to say we have 4 this thing, and we have to choose 2. We have to choose 2 numbers, right? So every time, because k we have been given 2, 4 plus 2. Don't consider this one. So this totally, when we consider 2 numbers with n equals 4, we will that will give us 6 combinations. Those 6 combinations we have been given here, right? So these are the 6 combinations, right? So this is fine. So same goes with second one as well. N we have been given 1, k we have been given 1. Your output definitely will get here as 1 because they are strictly mentioned the, I mean, they are given wonderfully in the explanation here. There is 1. We have to choose only one here. It is 1 equals 1 total combination. K we have been given 1, right? So we have to take one number at a time. And n we have to we have been given only 1. We have to consider from 1 to 1, right? So in this case we have to consider only 1 from 1 to 1. And k we have been given 1, only we have to consider 1 from 1. This is when we are done with the solution. Here is a breakout of the solution, right? So this is it for the second example. They have given us wonderful examples just for the sake of understanding, right? So let's do one thing. Now let's discuss the approach followed by the organizers and then let's first let's discuss the approach. See here, first of all I want to tell you that we will be going to the backtracking, right? So we will be going to the the recursion, right? So basically backtrack uses recursion itself, right? So we will be going to the backtracking approach of the recursion, right? So we will start with this one, MTI. We'll start with MTI, right? So first, let me consider this one, first output. So we have been given n equals 4. So we have to consider from 1 to 4. First, what we will do, we'll choose 1. We'll choose 1, right? And in the array, we'll consider 1. Then we will choose 2. This will be 1 comma 2, right? So this is fine. Next, we will choose 1 comma 3. So this will be 1 comma 2. Next, we will go into 1 comma 3, right? Next, we'll go with the 4. First, we have chosen only 1. This one we cannot consider because here we have been given 2. Two numbers we are considering 1 comma 2, 1 comma 3. Next, what we will do, we will choose 1 comma 4, right? 1 comma 4. This is also two numbers. This is valid as well. This one also will be considered. Now, we are done with 4, right? So this combination from 1, 2, 3 and 4, we are done. We have to consider, we have to choose 2 now. We have to choose 2 now. So here we will be considering 2, right? So this itself we cannot consider 1, and here 2, this 2 itself we cannot consider, right? So now what we will do, we will choose 3. First we will choose 3. So this will be 2 comma 3. This will be Next, what we will do, we have to choose 4 with the 2, nothing but this will be 2 comma 4. So this one will be valid as, right? So this one will be valid as, right? So we are done with this. We are done with the lookup. Next, what we will do, we will choose 3 now. We will choose 3, right? So only single number we cannot consider. So this itself we cannot consider. We have to consider one more number as k is 2, right? So we will be considering 3 comma 2. We have already got here 2 comma 3. For 3 comma 3, the same numbers we cannot consider, right? So the same number we cannot consider, right? So one thing here we are left with 3 comma 1. We have already considered 1 comma 3 here, right? So the same number we cannot consider 3 comma 3, 2 comma 2, 1 comma 1 we cannot consider, right? So this is fine. We have to go with the different combinations, right? So this is fine. Now we are left with only 3 comma 4. Yeah, 3 comma 4 we haven't considered, right? So we can consider 3 comma 4. We can consider 3 comma 4, right? So this one we can consider. We cannot choose 4, and we cannot go with this one 1 comma 4. We have already considered, and we cannot consider this one 4 comma 1. We cannot consider 4 comma 2 as well. This one we have already considered 2 comma 4. We cannot consider 4 comma 3 as well. This one we have already considered. We are left with 4 comma 4. Same numbers we cannot consider. So we will not be considering 4 at all. 4 will not be taken into consideration at all, right? So what are the combinations that we got? The tick mark I have given, right? So these are the combinations basically 1 comma 2, 1 comma 3, 1 comma 4. Let me write it over here. So this is nothing but 1 comma 2. The next tick mark here is 1 comma 3. Consider this one as well. The next tick mark is 1 comma 4. This one, this tick mark. So this one has to be 1 comma 4. The next tick mark here is 2 comma 3, 2 comma 4, right? So from 2. So this one is 2 comma 3 and 2 comma 4. Let me write this one down. 2 comma 4. The final one from the 3 we got 3 comma 4. From 4 we didn't get anything, right? From final one 3 we got 3 comma 4. So this is the, see here 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 4. This is the output that we got, which is exactly same as the output that they have given here for the example 1 with the question 1 comma 2, right? 1 comma 2, 1 comma 3, right? 1 comma 4, 1 comma 4, right? Next we have got 2 comma 3, right? So 2 comma 3. Next we have got 2 comma 4. Yes, we have got 2 comma 4. Final one we have got 3 comma 4. Yeah, we have got 3 comma 4 here. So uh, the output that we got is equivalent to the output that they have mentioned for the example 1 within the question. So I'll just delete this one. I hope the approach part is completely clear, man. I insist you to try out with the different examples. The second one is easier as you have only one value. So I insist you not to try this one. You have nothing to try here. So consider any other example, just try, right? So that you understand the question better, right? So this is fine. You understand the approach better. Sorry, not the question. Question is fine. We have to understand the question. So now let's do one thing. Let's discuss the complexities part very quickly, right? So we are done with the this one we call approach part. Now let's go with the complexities part. So what will be the time complexity here? This would be echo of C combination of n comma overall time complexity would be to echo of combination of n comma k. So sorry, this one n comma k into k into. This is fine. So why it is because the combination of n comma k into k. Just not this one because n comma k here, right? So this is because combination of n comma k into k, because we are generating each combination that takes this one because k copy time, because k copy time. So overall time complexity would lead to because c of n comma k into k. So this is the time complexity, right? So what would be the space complexity here? Space complexity is just because k, because we are making use of the backtracking, which make use of the recursion, right? So backtracking, quite obviously, backtracking is completely dependent on the recursion. So it is nothing but the recursion itself, right? So it is completely dependent on the recursion, and the recursion depth can go up to because according to the formula. Usually we consider in the form of n, right? Recursion, we usually say recursion depth can go up to because n. So here in this case we are considering k. So accordingly with the k, recursion depth can go up to this one because k, right? So overall space complexity would be because combination of n comma k. Sorry, this one is just the recursion type. Recursion type. Overall space complexity would lead to, so overall space complexity would lead to because k plus this one, because c combination of n comma k into k, for instance, right? So this would be because of k plus this one, whatever the name of this. So this one we have written because c of n comma k into k itself, right? So this is space complexity because k plus because combination of n comma k into k. So this is the overall space complexity. This is just the recursion type. Sorry, so this is fine. Let me delete this one. Right. So now we are completely familiar with the complexity and the recursion part. Right. So as we are completely familiar with the complexities and the recursion part, we are good to write the code. Let's start writing that. Right. So first, let's go with the result list to store all the possible combinations. I'll just go with the list here. This one is list. This is fine. So this one will be integer. This is also fine. And let me go with the result equals new. Let me go with array list here. This is also fine, right? So now let's do one thing. Let's go with the temporary list to store the current combination, right? So actually we went with the result list. Now let's go with the temporary list just to store the current combination. So this will be list of integer and bracket. So I'll just give current equals new array list. This is also fine. Now finally, let's call the backtracking function starting from 1, right? So to call the backtracking function that is starting from 1, we have to perform the backtracking or the recursive backtracking, right? So let's do that. So I'll not write it on, I'll not write the this one backtrack, this one backtrack, whole backtrack, this one within the main method, within the main method combine. Let's go with the helper method backtrack and let's make use of it within the main method combine, right? So let's do one thing. I'll just go with private here void backtrack. So let's go with the start and get parameters. So this one will be list integer. This is fine. Let me consider current here. Also, we have to go with the result variable as well, right? So I'll just go with the list. This is fine. So we have to consider the integer, right? So I'll just go with the integer. This is integer. So result variable should be considered. Fine. Now within this method, let's go with the base case. If the current combination size is equivalent to k, then we have to add it to the result. Simple. Let's write the implementation. That's what we have discussed in the approach as well. So this one will be current dot size. Size. Right. So if it is equal to k, then let's add a copy of the current. So this one will be result dot add of new array list. This is fine. Within the parenthesis, let me pass the current. Right. So we are just adding a copy of the current list here. Then this one. Next, let's do one thing. We'll not return anything for now. I'll just get the return keyword. This is fine. So now let's do one thing. Let's iterate from the starting number to n. So I'll just go with the for loop here. This one will be int I equals start. So this is fine. I less than or equal to n. This is fine. I less. So within the for loop, let's choose the current number. Nothing but current add of I. Current add of I. This is also fine. Now let's recurse with the next number. Right. So I'll just go with the backtrack. So this one will be I plus 1 n k. Let me consider n as well. So I'll just go with the so this is fine. The next thing is let's go with the backtrack. Let's remove the last added number. So I'll just go with current dot remove. This is also Fine. So this one will be current dot size minus 1. So this is also fine. So we are done with the backtrack method. We are done with the backtrack method. So this is fine. Yes, we are done with the backtrack method. So next let's do one thing. Um, let's call the backtracking function starting from 1, right? So become the main method. So I'll just go with, so let me copy this backtrack method and copy that like we have written. Okay, so go from backtrack. Okay, nothing but we have to call the backtracking function. It's starting from 1, right? So 1 we have to go with n. Also we have to go with k as for the input. Integer k, this is fine. So we have to go with the current as well. Also we have to go with the result. This is fine. Finally, the last step is we have to return the list of all the components that are stored in the result. Right? So this will be returned. This is it for the solution. Very simple, right? So let me format the code once and get back to the run button. Easy. Now we have this thing here. Fine, this simple. What am I here? I have also fine. Symbol variable current. Oh, this one I have given. So this one has to be done. Right? Let me run this one now. Yeah. Now we are getting the I mean the sample test cases are getting answered. Right. So let me hit the submit button very quickly. So here I go.